Welcome to Mickey Study Circle channel. In this video, we shall see how to do the computer drafting of the orthographic projection of solids using the Solid Edge software. Coming to the problem statement. A square prism 35 mm sides of base and 60 mm axis length rests on HP on one of its corners of the base such that the two base edges containing the corner on which it rests make equal inclinations with HP. Draw the projections of the prism when the axis of the prism is inclined to HP at 40 degrees and appears to be inclined to VP at 45 degrees. So let us draw a set of conclusions from this problem statement. So the first one being the type of solid mentioned here is a square prism, and the resting condition is it is resting on one of its corners such that the two base edges containing that corner are making an equal inclinations with respect to the HP. Also, coming to the inclinations with respect to the HP and VP, it is the axis which is inclined to HP at an angle of 40 degrees, and the axis appears to be inclined to VP at 45 degrees. So, the axis is the parameter which is going to change its length with respect to the first position and the second position. And this parameter is considered for the inclination with respect to the VP. So, which is well understood that it is a beta angle problem. But is the beta angle given here? Yes, because it tells that the axis appears to be inclined to VP at an angle of 45 degrees. So the problem statement itself mentions the angle to be a beta angle, and it is not the angle phi which is given to us. So with this data, let us see how to do the drafting of the solution for this problem statement. Let us begin by drawing a XY line of thickness 0.18 mm. So let us draw the line of any arbitrary length and annotate this line as x and y, and also the reference planes as VP and HP. Now let us draw the top view of the square prism which is resting on one of its corners. So for that, first let us draw the square prism of 35 mm length of the edges. So now let us select the square polygon and rotate it in such a way that it is resting on one of its corners, and that corner is towards the right hand side of the observer. So now you can just see that the angle of rotation here is 45 degrees, and this is the resting condition of the square prism. So now let us draw the diagonals of this particular prism so that we get the center of the two faces, and from there we can draw the axis. So now let us draw the projections in order to get the front view of the square prism. So from each of the corners, so we shall annotate the top and the front uh, faces of the square prism. So the top face is ABCD while the bottom face is A1, B1, C1, D1. So in the top view, the top face of the square prism is visible. So let us tell that it is resting on one of its corners A, and its corresponding corner at the bottom face is A1. Similarly, here it is corner B and the corresponding corner of the bottom face is B1, and here it is C and the corresponding corner is C1, and here it is corner D and the corresponding corner is D1. So the meaning of the problem statement which tells that the two base edges, that is AD and AB, which is containing this particular corner A, is making equal inclinations with respect to the HP. So this is the equal inclinations with respect to the HP. So now we will draw the front view of the square prism. So let us select the line of thickness 0.50 mm. So this marks the front view of the bottom face of the square prism, and the axis length given to us is 60 mm. So we shall draw the 60 mm line, and then we will complete the front view. And similarly, though there is an axis line, its corner line of this particular square prism, that is B1 D1, will be superimposed on the axis line, that is OO1. So that is the reason why this line is darkened and a separate axis line is not shown in the illustration of the front view of the square prism. And this is O and O1, that is the axis of the center point of the square polygon in the top and the bottom faces respectively. Now let us annotate the front view. So this is corner A1 dash, and for the observer here it is B1 dash which is visible, and inside the bracket it is D1 dash, and here it is the corner C1 dash. And also let us annotate the axis point, that is O1 dash. So just try to align all the corners on the respective lines so that it is visible properly. And now let us annotate the top face of the square prism. So this is A dash, and this is B dash inside the bracket D dash, and this is corner C dash, and also this is the axis origin point at the top face, which is O dash. Okay, so now we have completed the annotation of the front view of the square prism. So now he tells that the axis, that is O1 dash and O dash, is inclined to the HP at an angle of 45 degrees. So in order to construct that, let us select the front view of the square prism first, along with the annotations, and let us move this, ensuring the copy is on. So keeping A dash, A1 dash as the point of reference, let us just move this towards the right hand side of the XY line, and now select the rotate angle, and now we'll rotate the base of the square prism. So what is the inclination of the base? It is 90 degrees minus the angle of inclination of the axis with respect to the HP, which is 40 degrees. So the angle of inclination is 50 degrees for the base. So this is how it has to be inclined. So now let us try to extend this line, that is the axis line with respect to the HP, and then try to measure the angle. So we will select this line. So you can just use the split option. So this is the line that we're going to consider, and this part is to be split. So now you can just see that this is a separate entity. So we will just change the thickness of this line to 0.13 and then measure the inclination. So the angle of inclination is 40 degrees. So the reason why we consider it as 90 minus the angle of inclination is, you can just see that the angle of inclination here is 90 degrees, and the angle of inclination here will be obviously the 90 minus this axis inclination angle. So this is why we consider it as 90 minus the angle theta. So this is 50 degrees. So this is the construction of the front view of the second position, that is the axis is inclined to HP at an angle of 40 degrees. So now we shall complete this by drawing the top view. So for that, let us generate the vertical projectors downwards by selecting the line of thickness 0.13 mm. So let us draw the projectors from the respective corners. And let us draw the horizontal projections. So now let us complete the top view of the square prism. So we'll start from the corner A to the corner B to the corner C to the corner D and back to corner A. So how do we judge the hidden lines here? So if the observer is going to look from this direction, for him the farthest point of vision is the corner A1. So all the lines originating from this particular corner, that is A1, will be the hidden lines. So that is the thumb rule, we can tell. So now we will generate the hidden lines first. So from the corner A1, so this is where is the corner A1. So from the corner A1 to this B1, it will be a hidden line. And similarly from the corner A1 to the corner D1, it will be a hidden line. And similarly from corner A1 to A dash, it will be a hidden line. Okay. So now all the other lines will be the thick lines. So we shall just complete this. So intersect them with the point of intersection and the endpoints carefully and join the corresponding edges. So now it will be superimposed on this edge, and this is the final view. So we can just use the trim option to trim this lines, and then the axis line will just end here, so this part is not required. So however we require this axis, so we shall just trim this line so that this entire line will be one single entity for us. So now you can just see this. The dimension of the axis in the first position is 60 mm, but when I consider the dimension of the axis in the second position, that is from here till here, it is reduced to 45.96. So this axis is the condition which is to be considered for the third position for inclination, and since it has changed its dimension, it will be a beta angle problem. But however here the word appears to be suggests that the given angle itself is the beta angle. So now let us try to annotate this top view of the square prism. So this is corner A, corner B, corner C, and corner D, and followed by this is corner A1. This is followed by corner B1, and this is C1, and this is corner D1. And these are the points of the axis line. So this is O, and this is O1. So now we'll go for the construction of the square prism when it is inclined to VP along the axis at an angle of 45 degrees. So for that, let us consider constructing a line of thickness 0.13 in such a way that it is making an inclination of 45 degrees with respect to the VP. So you can just check it out. So the angle of inclination here is 45 and here it is 40. So now we shall select the prism. So before selecting it, ensure that you use the rigid option. So now go for the rigid option, make it a rigid set till accept, and now it is a rigid set. So now let us consider the square prism for inclination with respect to the VP along with the annotations. So the entire prism is selected. So now let us go for the move option, ensure the copy is on. So we will move it from this point, that is O1, and ensure that it is placed on this 45-degree line. And then we will go for the rotate option. So from this point of intersection to the next point is this O1. So we're going to incline, ensuring the copy is off in such a way that the axis is inclined to the vertical plane in this particular fashion. So this completes the inclination of the square prism with its axis at an angle of 45 degrees to the vertical plane. So now let us try to generate the front view of this condition by drawing the horizontal and the vertical projections. So there is a very minute difference between this projection line. So just use the angle condition, that is of 0 degrees, and try to extend this. So this is the locus of the corner C1. So now let us consider the top face. So corner A, it has to intersect with this corner A here, and similarly from B, let us try to intersect that with the projection from B, and from corner C, it has to intersect the projection from the corner C, and similarly from corner D, it has to intersect this. So we'll first try to construct the top face and the bottom face, join the corresponding rectangular faces, and then go for the hidden lines. So now let us go for constructing the top face of the square prism. So let us start with the point A, and finally with the point B, C, D, and back to the point A. So this is the top face of the square prism. So now let us draw the projection lines from the bottom face of the square prism. So let us start from the corner A. So it is on the XY line, and similarly from B, it is here on this line. From C, it is this line, and similarly from D, it is here. So now we shall construct the bottom face of the square prism by selecting a line of thickness 0.50 mm. So let us begin from the point A, which is on the XY line, take it up to point B1, and similarly to the point C1, back to D1, and then back to A1. So now let us join the corresponding edges. So before that, let us try to annotate so that there are no confusions while joining the rectangular faces. So this is C dash, and this is B dash, this is okay, this is D dash, this is B dash, and this is A dash. And next, coming to the point on the XY line, which is A1 dash. Similarly, this is B1 dash, this is D1 dash, and this is C1 dash. C1 dash. Okay. So now we will join the corresponding edges. So to avoid the confusions, let us just try to trim the lines, which is done with the projections. Okay. So now let us use the line option to join the edges. So A dash to, okay, this is C1 dash. So okay, let us begin from A1 dash to A dash, D1 dash to D dash. Similarly from C1 dash to C dash, and finally from B1 dash to B dash. Okay. So what are the thumb rules that we need to follow? First, we need to identify the farthest corner point. So the farthest corner point is D1. So from the farthest corner point, all the lines shall be the hidden lines. And also No two thick lines shall intersect, nor no the two hidden lines shall intersect. So from D1, so this is the corner point D1. Let us make them the hidden line. Okay, here the farthest corner point is the corner A, not D1. So let us just undo this. So let us select. Okay, so we have made a small mistake here. So this is D1 and this is B1. So we have to just interchange those points. So let us try to rectify that. So this will be corner B dash and this will be the corner D dash. So the farthest corner point is the corner D, and all the lines emerging from this D will be hidden lines. So with this we complete the problem. So let us try to mark the axis also, which is very important. So let us draw the axis lines. So we have got the point O1 here, which shall intersect the axis line from O, and similarly from this. Okay, so we shall just try to measure this. In case if this happens, you can just go for the distance between this point and point of intersection, which is 15.91, and let us try to draw a reference line from A on this, which is 15.91, and from here let us try to intersect the axis line. So now let us draw the axis line by selecting the chain line of thickness 0.13 mm. So this is the axis of the square prism. Let us annotate this. So the axis point on the front, on the top face of the square prism is O dash, and similarly the axis point on the top faces, on the bottom faces O1 dash. So with this we complete the solution for drafting the square prism resting on one of its corner and its axis inclined to HP and VP at an angle of 45 degrees. So let us just try to indicate the direction of the projection lines. So with this we have completed the drafting of the solution for the square prism resting on one of its corners and inclined its axis with respect to the HP and VP at an angle of 40 degrees and 45 degrees as per the problem statement.